kilobytes 8 EEPROM and 8 kilobyte ERAM chip with Intel 8086 microprocessor, and we are going to develop the suitable address mapping and interfacing diagram to interface these two memory chip with Intel 8086 microprocessor. Here we are going to interface the two types of memory. One is 8K into 8 EEPROM memory. Another one is 8K into 8 RAM type memory. Here the 8K is represented as capacity of the memory capacity. So we can able to store maximum 8 kilobytes of information in EEPROM as well as RAM type memory also. This 8, it will be represent the number of bits we can able to store each memory location. For example, my memory chip has 8K into 4 means we can able to store only 4 bits of information in each memory location. So this is this 8 it represent. To interface the memory with microprocessor, the first step is step 1 is calculate number of IC we require. In Intel 8086 has 16-bit data bus, 20-bit address bus. This data bus start from D0 to D15, address bus start from A0 to A19. So we needed to process this 16-bit data simultaneously. We need two 4K into 8 EEPROM and two 4K into 8 RAM chip needed for simultaneously accessing the 16-bit data from microprocessor to memory. This concept we already discussed in the memory banking in Intel 8086 microprocessor. Now we need 4 ICs to interface the 2 EEPROMs and 2 RAM chip with the microprocessor. Next, step 2. In this step 2, arrange the given memory chip as odd and even banks. So we are going to interface 8K EEPROM and 8K RAM memory. This 8K RAM memory, it divided into odd memory bank and even memory bank. to simultaneously accessing the 16-bit data from microprocessor to memory. So 4K EEPROM memory for hard bank and another one 4K EEPROM memory for even bank. Similarly, RAM memory also 4K RAM for hard bank, 4K RAM for even bank. So now my memories are arranging like that. So odd memory, even memory. Here we can able to store the 8 bits of information in odd bank, another 8 bits of information in even bank. This 8 bit for EEPROM memory, another odd bank are available, that is for RAM memory. So here we can able to store 8 bits of information. In even memory we can able to store the 8 bits of information. Step 3. Step 3. Calculate the number of address lines needed to interface between microprocessor and memory. Microprocessor to memory. To interface the 8K EEPROM and RAM memory, we need 13 memory address lines are needed as per our formula. The formula is log 8K divided by log 2, we get 13. In Intel 8086 microprocessor having the 20-bit address lines, in this 20-bit address lines A0 to A13 shared between the memory to microprocessor. Okay, so this A0 to A13 lines are shared between microprocessor to memory. Remaining lines, A12, remaining lines A13 to A19 we used to generate the control signal for selecting the individual RAM and ROM type memory, or to generate the required chip select signal to activate the individual RAM and ROM type memory. Along with A13 to A19 we also include the BHE signal and A0 signal to select the respective RAM and ROM type memory, odd bank and even bank.